Good morning. Today is April 21st, 2020. Our lesson for the day is students will be able to find equivalent fractions and compare in order by using various methods. So we have gone over how to find equivalent fractions. We've gone over comparing and ordering fractions before, so this is just a review, a revisit on some previously taught strategies. And we're going to be using various methods. So if you have been in my class or you've been with Mr. K, there's ways that we have taught you how to compare and order and find equivalent fractions. If you're in my class, one of the ways that you've seen this anchor chart, first thing that I like to have my students do is to find a benchmark fraction. Is it more or less than half? 3/4, is more than half, so I just have them put an M, and 2/6 is less than half. If you don't know how to find if it's more or less, well, think about what is half of your denominator. So half of 6 is 3. So I know that 2 is less than 3, so this fraction is less than 1/2. And then I know that half of 4 is 2, and 3 is more than 2. So 3/4 would be more than. So I already know which one is greater. I know that 3/4 and 2/6 are not equivalent, and 3/4 is greater. We've talked about drawing pictures. We don't use that one quite as often. But we can also think about 3/6 and 2/12. We want to see if they're equivalent. So we look at our denominators because we need to find a common denominator. That means both of them have the same amount of pieces at the bottom. So is there any number I can multiply times 6 to get to 12? Yes, there is. I can multiply 2 times 6 to get to 12. And so then when I multiply, whatever I do to the bottom, I do to the top. So 2 times 6 and 2 times 3 gives me a new fraction of 6/12. So I see that this is now 6/12, and then I have 2/12. Well, now that I have them both in the same denominator, I can clearly see that they are not equivalent and that 6/12 is larger. So I will put my comparison symbol facing the 6/12. And then strategy, another one that we use is finding the common denominator. So I'm going to list the multiples of 8 and 6 here. I've already listed those multiples of 8 and 6 to see if I can come up with the common denominator. And both of them, the common denominator is 24. So whatever I do here to the 8, it took 1, 2, 3 times to get to 24. So 3 times 24 is the same thing I do to the bottom, I do to the top. And then for my 6, it took 1, 2, 3, 4 times. So I would multiply 6 times 4 and 2 times 4, which gave me two new fractions of 9/24 and 8/24. Well, they're both in the same denominator, and it's the lowest one that I could find. So 9/24 is greater than 8/24. And many of you use this strategy here, which is cross multiplying or the butterfly method, where I multiply this denominator times this numerator to give me 16, and this denominator times this numerator to give me 25. I don't stop there. I have to find a common denominator. So I multiply 8 times 5, which gives me 40. So now I have two new fractions of 25/40 and 16/40. Sometimes your fractions get large using the butterfly method, just as long as we can see that these two are not equivalent, that 25/40 is larger. So whichever strategy that you use to get to see if it's equivalent, or to see if which one is greater or less than, that's fine with me. All right, so we're going to be comparing 2/3 and 3/4. So the first thing, I've just trained my brain to think 2/3. Well, I know that that is more than half, because half of 3 is 1.5 or 1.5. So 2 is more than that. So this fraction is more. And then 3/4 is more as well. So since both of these are more, then I have to use one of my other strategies. I'm just going to go ahead and do the butterfly. So I'm rewriting my fractions. Are there other ways that we can get to it? Yes, we sure can. We can list our common denominators. But for today, right now, I'm just going to cross multiply. So here I have 2 times 4 gives me 8. And 3 times 3 gives me 9. But I'm not finished because I have not created two new fractions. I need to multiply 3 times 4, which gives me 12. So now I have 8 twelfths and 9 twelfths. And just to make sure that I know which one is which, 8 twelfths is equivalent to 2/3, so I'm going to put that here. 8 twelfths is equivalent to 2/3, and 9 twelfths is equivalent to 3/4. So now I have two new fractions with a common denominator. Now I need to compare. Well, 8 and 9. Since my denominators are the same, I'm just looking at my numerators, 8 and 9. Which one is larger? 9. So my 9 twelfths gets 2 dots. And then I'm going to connect my dots to make sure my comparison symbol goes the same way. Now, we could list our multiples. Yes, we could. I could list my multiples for 3. And I could list my multiples of 4. So my multiples of 3 are 3, 6, 9, 12, and 15. I'll stop there. And then my multiples of 4 are 4, 8, 12. Oh, I found two numbers that are the same. So here's my 12 and my 12. It took me 1, 2, 3, 4 times. So I will multiply my 3 times 4. Whatever I do to the top, and I do to the bottom, times 4. And then it took me 1, 2, 3 times over here. Times 3. So now my new fraction is still going to be 4 times 2 is 8, and 4 times 3 is 12, and 3 times 3 is 9, and 4 times 3 is 12. So either way it comes out, I'm still getting the same answer. Moving on. So in class we practiced on solving these ourselves. Now when I have 1/4 and 3/4, well, my denominators are the same. So I don't have to do too much of anything because it's 1 out of 4 larger or 3 out of 4. Well, I know that 3 out of 4 is larger. So I'm going to go ahead and draw it here. 1/2 and 1/8. Well, my denominators are different. But look at my numerator. This is saying that I have 1 out of 2 pieces, or I have 1 out of 8 pieces. When I'm looking at one piece out of each one, would you rather share it with 2 people, or would you rather share it with 8 people? So when I look at this, I know automatically that 1/2 is bigger because this is more, well, this is half. And this one right here is less than half because half of 8 is 4. So I didn't have to do too much hard work on this one. Right over here, 2/4 and 7/8. Well, is it less than, more than, or equal to half? What's half of 4 is 2. So I know that this fraction right here is half. And 7/8, well, what's half of 8 is 4. So 7 is more. My work is already done. Could you use a butterfly? Yes, you could. But sometimes it takes more doing that. And then 1/8 and 1/2. Still the same thing, just right over here. I know that 1/2 is greater. Now, when I'm looking at fractions, and I can use a picture model as well to see if a fraction is more or less than half, or if there are equivalent. So I've done this first one. So when I have a pictorial model, the first thing I like to do is label my picture. So this is 1/2, and this second one is 5/10. So look in here, is 1/2, well, it's exactly half. And 5/10, well, what's half of 10 is 5. So this right here, they are both equivalent. 1/2 is equal to 5/10. So let's look at this next one here. We want to count up the total number of pieces that we have. 1, 2, 3, 4, 5. my denominator, and how many are shaded? 2. So I have 2/5. Now look over here at this next one. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many is shaded? 1, 2, 3, 4. So I have 4/10 on this side. So now looking at this, well, half of 5 is 2.5. So this is less than half. And half of 10 is 5. So this is less. So now I have an option. I have some different strategies I can use to solve this. 2/5 and 4/10. Both of them are less than half, so I need to see, are they equivalent? So I could cross multiply, but for this one, I want to see, is there any number times 5 I can multiply to get to 10? It sure is, and it's 2. So if I multiply both my numerator and my denominator by 2 times 2, which gives me a new fraction of 4/10. So now I have 4/10 and 4/10. These are equivalent. Well, let's look at this one right here. Could I have done butterfly method? Yes, I could have. But I would have came up with a larger number. I would have actually came up with 5 times 4 is 20. And 2 times 10 is 20. And then 5 times 10 is, 5 times 10 is 50. So I would have came up with 20/50ths. Still 2 equivalent fractions, just larger. I'll come down over here, 1/2. Oh, sorry, I put 1/3. That was 1/2. And this is 1/3 here. Well, my denominators are different, but look at your numerators. My numerators are the same. I have 1 out of 2 pieces or 1 out of 3 pieces. So just looking at this, I can see from my picture that 1/2 is larger. So they are not equivalent. And then looking over here, I have 1, 2, 3, 4, 5, 6 total pieces. One of these is shaded. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 2 of them are shaded. Well, yes, I know before over here, because both of my numerators were the same here. My numerators here are different, and my denominators are different as well. So, both of these are less than half. And I want to think, is there any number I can multiply times 12 to get to 6? No, but there's a number I can multiply times 6 to get to 12, and that's 2. So I'm going to go ahead and multiply the numerator and the denominator by 2. Could you cross multiply? Yes, you could. 2 times 1 is 2. 6 times 2 is 12. So now I have 2 12s. If I cross multiply, that would give me 12. Oh. And this side over here would give me 12 as well. And then when I multiply 12 times 6, that gives me 72. So yes, I still could see that these fractions are equivalent. Alright, so now if we want to order from the least to greatest, or the smallest to the largest, I would just put what I see here for each one. So here I have 1/2. I have 1, 2, 3, 4, 5, 6. And one of them is shaded. I have 2, 4, 6,